This lesson comes from Unit 1, Chapter 1, Section 1.6, Surface Area and Volume of a Sphere. In this lesson, you will learn how to develop and apply formulas for the surface area and volume of a sphere, and how to develop formulas for the surface area and volume of a hemisphere. Before we get started, it is important to notice the definition of a sphere. A sphere is an object where every point on the surface of the object is the same distance from the center of the object. This object, the sphere, may be new to you, therefore let's take a further look. A sphere consists of two components. First, the radius. The radius is a line segment that joins the center to any point on the sphere. The diameter is a line segment that joins 2 points on a sphere and passes through the center. The radius and diameter of a sphere is very similar to the two-dimensional circle. The radius will extend from the center to one side of the sphere, while the diameter crosses through the center and passes through both sides of your sphere. If we think of an orange will approximate a sphere, and the area of its peel will represent the surface area of a sphere. Some other examples of spheres would be a tennis ball, a marble, a basketball, a globe, and again an orange. The surface area of a sphere is related to the curved surface of a cylinder that encloses it. The cylinder has the same diameter as a sphere and a height equal to its diameter. From here, as we can see from the diagram, the sphere is enclosed in the cylinder. If we look at the formula as given, we can develop the formula for a sphere. Keep it in mind that a cylinder has a curved surface and two circular areas. At this time, we are only concentrating on this curved surface. Remember that the curved surface of a cylinder is represented by 2 pi r h. The radius of the sphere and the radius of the cylinder are the same. However, if you notice, the height is represented by 2r. If we replace h for 2r, our formula will now become 4 pi r squared. Again, the surface area of a sphere is exactly 4 times the area of a circle with the same radius. A circle will have a surface area of pi r squared. Looking at the cylinder and the sphere, we can see how the formula for the sphere is also developed through the relationship of a sphere and a cylinder. The surface area, therefore, of a sphere is equal to 4 pi r squared. Let's look at an example to confirm this formula. If we're given a basketball that has a radius of 12.5 centimeters, we want to determine how much leather in centimeters squared is required to cover the basketball. In the diagram, we can see that the radius is given and not the diameter, so we can substitute 12.5 centimeters in for the radius. So the surface area equals 4 pi times 12.5 centimeters squared, for a total of 1,962.5 centimeters squared. Next, the volume of a sphere is represented by 4/3 pi r cubed. Keeping in mind that surface area is a squared unit, while volume is a cubed unit. Next, given a sphere, we know that it is a perfectly symmetrical shape. There are no edges or vertices. However, a hemisphere is a little different. A hemisphere is half of the Earth. For example, a northern hemisphere or a southern hemisphere. As you can see from the diagram, a hemisphere is half of a sphere. When a plane cuts across a sphere at its center, it will form 2 hemispheres. In the diagram, you can see we are looking at one hemisphere. If we look at the surface area and volume formulas, how are they developed or formed from the formulas of a sphere? Let's first look at surface area. Surface area of a hemisphere is equal to 3 pi r squared. This is developed because first the rounded edge or the curved surface of a hemisphere is represented by 2 pi r squared. The base of the hemisphere is a circular object. The surface area of a circle is represented by pi r squared. Therefore, the complete surface area of a hemisphere is 3 pi r squared. Next, the volume of a hemisphere is 2/3 pi r cubed. If we had to go back and look at the volume of a sphere, we know that a hemisphere is half of a sphere. Therefore, you take the volume formula of your sphere and cut it in half. This will result in 2/3 pi r cubed. Now, in summary, the formulas for a sphere and a hemisphere are given. Surface area of a sphere is 4 pi r squared. Volume of a sphere is 4/3 pi r cubed. Again, a hemisphere is half of your sphere, so the surface area is 3 pi r squared. The volume is equal to 2/3 pi r cubed. In the next section, we will look at some examples of composite objects involving a sphere and a hemisphere.